In this first picture right here, if I'm looking at the planes that crisscross and one slices through the middle, there's one and only one point that all three of these planes share. So it will have one solution. There's one solution to this system, and it is an x, y, z triple. It's a point with an x and a y and a z coordinate, which means if I graph x, that's left and right, y is up or down, and z is either out towards you or into the board. So it's in 3 dimensions. So I could have a situation here where I've got two planes, and the only point where the two planes that crisscross and the plane they're sitting on meet is, again, that one point. I have an x, y, z triple, or a triplet. So I also have a situation where I can see these 3 planes. There's like the whitish color, the dark purple, and the lavender. All of these share one axis. So they have one line in common. But how many points are on a line? Infinite, right? So this has an infinite number of solutions. There are an infinite number of points that all 3 of those planes share. Every single point that's along that line is shared by all 3 planes. Well, each one of those planes would be like an x plus y plus z equals 13, an x minus y plus 2z equals 35. And so there's 3 equations. I've got an equation for that plane, an equation for that plane, and an equation for that plane, and all 3 are in 3 variables. But they will share all along the y equals mx plus b line. There are an infinite number of points on that line, so I have an infinite number of solutions. Let's see. Like that. So you'll have 3 variables. Then the last situation here, I have on this last picture, this one right here, any 2 planes intersect, right? So I've got this plane and this plane that intersect, this plane and that plane that intersect, but there's no place that all 3 intersect at the same time. The same true down here. I've got these 2 planes intersecting, or I've got these 2, or I've got those 2, but there's no solution where all 3 intersect at the same time. So we're going to do the same thing. You can do pure substitution or pure elimination. You don't have to do Gaussian elimination to solve these. However, I am here to tell you if you do pure substitution or elimination, you have to take equations 1 and 2, then equations 1 and 3, then write a new system, then solve the new system, and it's very, very many steps, and it usually confuses students, so you end up plugging the same thing back into the same equation, and you go in this little circle on your paper. So in order to avoid that, I will show you Gaussian elimination. That's the way I am going to do them. In 12 years of teaching, it is the most straightforward, least likely for you to make a mistake. If you would like to learn either pure substitution or elimination or would like to apply that, you can either come in and see me before school, after school, or at lunch, or read your textbook, or go online, and you're welcome to do it that way. As long as you get the right answer and I can follow your work, you're okay. But I'm not going to teach it that way because you're more likely to make mistakes. This is a much more straightforward way. So we're doing the same steps you did on, Friday of last week, Thursday of last week? Same exact steps. We're just introducing 3 variables. So our goal on all of these equations is to get them in row echelon form. And we're going to do the same thing. We're going to either multiply, switch rows, or do a combination where we add them up, multiply, in order for things to cancel. So row echelon form looks like this. In 3 variables, I'm going to have a column for x, a column for y, a column for z, and a column for my constants. If it is in row echelon form, I'll have a 1 here and numbers everywhere else. They could be zeros, I don't know. Then I'll have a 0, a 1, and numbers everywhere else. Then I'll have a 0, and 1, and a number here. And that's what we call row echelon form. When we get into row echelon form, like this equation right here, he's already in row echelon form. So we've got 1, 2, 3, 9, 0, 1, 3, 5, 0, 0, 1, 2. He's in row echelon form if I had him written as a matrix. Once we do that, we're going to do the same thing we did last time. We're going to use back substitution. So if I've got z, I'm going to go back to the equation before that, and I'm going to plug in what I know z is. So if I have y plus 3z is 5, but I know z is 2, I have y plus 3 times 2 is 5. So when I use back substitution, I can solve this next equation, and I get y is -1. Then I go back again, and I go to the x, y, z equation, but now I have y and z. So where I have x minus 2 times y is -1, plus 3 times z, but z is 2, equals 9. And I go back until I've solved for all the variables. So x plus 2 plus 6 is 9, or x plus 8 is 9, or x equals 1. So for this system that's already in row echelon form for you, your x, y, z point would be 1, negative 1, 2. So that's what we're going to do today. I'm going to give you a system of equations. We're going to put it in our matrix form. We're going to do elimination. We're going to go back and solve for each variable and write the answer. Whatever your last equation is. If I look at this last equation right here, this equation says no x's, no y's, z is equal to this number. So z will always be equal to whatever that number is. Well, remember, when I put these in order, these are all x's, these are all y's, these are all z's. There's an understood equal sign down here, and those are all my constants. All right, so we're going to work one all together from beginning to end. Are we ready? Ready or not? All right, write these three down for me. Just write them down, then we'll do it all together. So let's go ahead and write this. So the first equation, row 1, I have 1x, negative 2y, 3z is equal to 9. For row 2, I have negative 1x, 3y's, no z's is equal to negative 4. And in the last equation, I have 2x's, negative 5y's, 5z's is equal to 17. My goal is row echelon form. In row echelon form, the very first row starts with a leading coefficient of 1. And we're there, right? Row 1 starts with a 1, we're good. My next step is to get rid of the first variable in the second equation. So I want to get rid of whatever the first variable is in the second equation. And I can switch equations, but right now I want to get rid of that term. I need him to become a 0 to put everything in row echelon form. So what could I add to a negative 1 to make it a 0? 1. But look, I have a 1 somewhere. Where do I have a 1? So all I'm going to do is I'm going to add row 1 plus row 2, and I'm going to replace row 2. So 1, negative 2, 3, 9. I'm not changing row 1. I'm not changing row 3. The only thing I'm changing when I add two things together is the latter equation. So I'm going to replace row 2. So 1 plus negative 1 is 0. Negative 2 plus 3 is 1. 3 plus 0 is 3. 9 plus negative 4 is 5. So row echelon form, the very first row starts with a 1. We're good. The second row starts with a 0. We've eliminated the first variable, which is x, and then y starts with a 1. So we're good. So now for row 3, I need to get rid of the very first variable. I need to get rid of x. And I need to do these in order so that it's less likely to make a boo-boo. So I need to get rid of this guy. So what would cancel a 2? Where could I get a negative 2? So I could say negative 2 times row 1 plus row 3, and I'm going to replace row 3. So this is what you should be writing on your paper so I know what it is you're doing. Because on your quiz, if there's only one of these, I'm going to go follow your work. And if you make a little boo-boo, but the rest of your work is correct, I will follow your little boo-boo all the way through, and you'll only lose a few points. But if all I have is a random answer, and it's completely wrong, and I see no work, and I can't tell what you did, then that's when we get into the situation where it's like kind of all or nothing. But if you only make 2 little boo-boos, but they're little, they're arithmetic errors, I can find those and I can trace them all the way through to your answer. It just takes a long time to grade those quizzes. All right, 1, negative 2, 3, 9. We're only replacing row 3, 0, 1, 3, 5. So I said negative 2 times row 1, so negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times row 1. So negative 2 times this whole row, right? So negative 2 times negative 2. 4 plus negative 5. Negative 1. Negative 2 times 3. Plus 5. Negative 1. Negative 2 times 9. Plus 17. There we go. So row echelon form, row 1 starts with a 1, we're good. Row 2, I have a 0, then a 1, we're good. Row 3, I have a 0, then a 0. So now, my goal is to get rid of this variable. So what will cancel with a negative 1? A 1. Now I've got to be careful where I get that from. If I add row 1 and row 3, what's going to happen in the x column? I'm going to get a 1 back, right, or a number back. So I only want to add rows 2 and row 3 because I need the x's to stay 0. So if I add row 2 and row 3, will the middle guy be gone? All right, so that's what we're going to do. We're going to add row 2 plus row 3, and we're going to replace row 3. So 1, negative 2, 3, 9, 0, 1, 3, 5. If I add these two rows, 0 plus 0 is 0. 1 plus negative 1 is 0. 3 plus negative 1 is 2. 5 plus negative 1, same as 5 minus 1, is 4. So the first row is in row echelon form. The second row, 0, 1, we're good. The third row, 0, 0, what should this guy be? A 1. So what can I do to make him a 1? So we multiply by half. We typically say we multiply everybody. Dividing by 2, multiplying by half, they're the same thing. So 1, negative 2, 3, 9. 0, 1, 3, 5. Times a half, times a half, times a half, times a half. And now I'm in row echelon form, which means I've inherently solved for the last variable. In row echelon form, when I go back and write equations, the top equation is going to be x minus 2y plus 3z is 9. The middle equation, I don't have x, I just have y plus 3z is 5. And the last equation, I don't have an x or a y, I just have z is 2. And now I have to go back. Once I have z, I go to the equation that has just z and y, and I plug it in and I find y. Then when I have y and z, I go back to the first equation. Do you notice anything? About this one, though. Should look really familiar to you, because this is the one I just started class with. This is the one you just did back substitution on. So you've already found the answer. So if z is 2 and you plug that back in, y would be negative 1 and x would be, what did we get on the last problem? 1. So there's our answer. So this system of planes has one solution. It's the point 1, negative 1, 2. Questions? Huh? Yes. No solutions and infinite solutions.